So what if the whole point of science isn't actually to find some kind of absolute truth? It's a bit of a weird thought, right? Well, today we're going to explore a really powerful and maybe even a little unsettling idea about what physics is really trying to do when it describes our world.
This quote right here, it just flips the whole script. We tend to think of physics as this set of perfect, rock-solid laws. But what if it's not a perfect mirror of the universe? What if it's just our best, honest attempt to say something meaningful about it? That one little shift in perspective, man, it changes everything. Okay, so that leads us to the big question for today. What does it even mean for a science to be honest? And to figure that out, we have to go all the way back to the most fundamental, most basic assumption we make about the world, every single day without even thinking about it.
To really get this honest attempt of physics, we first need to look at how we build our own reality in the first place. And believe it or not, it doesn't start with some grand, complex theory. Nope, it starts with a simple, almost primal feeling.
I mean, really think about it for a second. From the moment we're aware, we feel this separation, right? There's an I, and then there's a world, a me, and everything else. This feeling, this perceived divide, is basically the starting pistol for our entire way of thinking. It creates this problem that we just have to solve. We've got to make sense of all that other stuff out there.
In this feeling of being separate, it sets off a kind of chain reaction. First, it creates this deep need to catalog, to quantify the world around us. So what do? We invent a tool, numbers. And what do we use those numbers on? We start grabbing bits of reality, grouping them together, and slapping names on them. That's a tree, that's a rock, that's a star. We literally construct the idea of object.
And the end result of all this is our common sense view of reality, the one that feels so obviously undeniably true. The world is just made of a bunch of separate, distinct things. This becomes the very bedrock of how we think. But, and here's the big twist, what if our most advanced science tells us this obvious truth isn't really true at all?
Okay, this is where things get really wild. This is where our comfy, common sense world starts to, well, fall apart. And it happens the moment we try to look at it as closely as we possibly can. So when physicists zoom in, I mean way down to the quantum level, something absolutely astonishing happens. Those neat, tidy, separate objects we built our whole reality on, they just dissolve. The clear boundaries between, say, a particle and its environment, or even between the person looking and the thing being looked at, they just vanish into this weird sea of probabilities.
So now we're left with two totally different views of reality. On one hand, you've got our classical, obvious assumption. The world is made of distinct objects, and we are separate observers who can measure their state. But then there's quantum reality, which suggests something so much stranger. It says that distinct objects are just an illusion of our big macro world. It says the observer and the object are all tangled up, and wildest of all, that a thing might not even have a definite state until we mess with it. So what on earth did physics do when its most basic assumption just completely collapsed?
Well, it did what any good problem solver would do. It invented a workaround, a brilliant, incredibly powerful, and deeply strange solution to a problem that honestly threatened to stop science in its tracks.
The solution was quantum mechanics. But here's the thing, it's not what you might think. It isn't necessarily a description of what reality is. A better way to think about it is as a powerful mathematical trick. It's a tool that lets us make ridiculously accurate predictions, even if we don't fundamentally have a clue what's really going on underneath it all. It allows us to calculate without actually needing to comprehend.
You could almost think of it like a survival mechanism for physics itself. Our whole idea of objects failed us at the smallest scales, so we built this incredible mathematical engine to keep the whole project moving forward. And it works. It works perfectly. But it comes at a price. We start to drift away from describing the physical world and into something else entirely.
And that brings us to the really profound consequences of relying on this mathematical trick. We start to blur the line between our own invention and reality itself. So when physical objects as a concept pretty much failed, physics kind of retreated. It started talking less about actual things and more about abstract fields, which are basically just mathematical grids where every single point in space has a value, a number attached to it. We started describing the map, this virtual world of math, instead of the actual physical territory it's supposed to represent. And this leads to a really dangerous idea.
This quote just nails the danger perfectly. When we start saying things like the universe is math or reality is made of numbers, we're making a huge mistake. We're confusing our tool for the thing it's supposed to describe. We're getting totally lost in our own virtual world, a world that could be, like the source here says, far from the truth.
And this reveals an even deeper problem. Our very tools, the things we use to do science, they create distortions. I mean, every time we put a point on a graph or assign a letter like X to some value, or even just name a phenomenon, we are chopping up what might be a continuous, unified reality into little separate pieces. These tools are absolutely essential for our work, but in a way, they do a kind of violence to the wholeness of the world.
Which brings us right back around, full circle, to where we started, back to that opening idea and the real, true beauty of this whole scientific enterprise.
And this is it. This is the heart of the whole thing. The honest attempt isn't about finding some perfect final answer. The real beauty is the integrity of the struggle itself. It's about using our distorting tools, our numbers, our theories, our graphs, while being rigorously, brutally honest about the fact that they are just tools, and that they might not be showing us the full picture.
So the beauty of physics at the end of the day isn't that it's right in some absolute final sense. The beauty is in the humility. It's in the sincerity of the effort. It's this relentless, incredible push to connect our limited, object-obsessed minds with a universe that is probably far, far stranger and more unified than we can ever truly imagine.
And that leaves us with one last question to just chew on. After all our counting and our naming and our measuring, what does reality actually look like before we impose all of our own ideas onto it? Before we ever draw that very first line?